morning students. It is video number 25 of class 8th chemistry. We will continue with the lesson number 6 chemical reactions. It is part 4. Now we will discuss double displacement reaction. Double displacement reaction. The positive radical and negative radicals of two reactant are exchanged, leading to the precipitation of product. Double displacement reactions are very fast and the precipitate is formed as soon as the reactant come in contact with each other. So the color of precipitate is also different from the color of reactants. Now we will discuss some examples related to double displacement. So first example is reaction between silver nitrate and sodium chloride. Formula of silver nitrate AgNO3 and formula of sodium chloride NaCl. When an aqueous solution of silver nitrate and aqueous solution of sodium chloride, which are colorless, mixed together as a reactant, they form silver chloride, which is white in color and it is precipitate. And another product we will form sodium nitrate in aqueous form, which is colorless. So AgCl is a formula of silver chloride. This is the example of double displacement in which the positive radical and the negative radical exchange like this and they form the product. You can see the diagram in which they are adding the two solution, silver nitrate and sodium chloride, and in this way silver chloride white precipitate will form during the reaction and sodium nitrate, that is colorless product, will form. The second example is the reaction between barium chloride and sodium sulphate. What is the formula of barium chloride? BaCl2. And what is the formula of sodium sulphate? Na2SO4. When these two given reactant in aqueous form react with each other, then positive radical and the negative radical exchange to form product. Precipitate formation will be there. The barium sulphate BaSO4 formed as a product in precipitate form, which is white in color, and the second product we get sodium chloride, which is colorless. And in product formation, white precipitate, it will be settled down in the test tube. Similarly, when lead nitrate combined with sodium sulphate in aqueous form, they formed lead sulphate and sodium nitrate product, and lead sulphate, that is in precipitate form, and another product, it is colorless, and after this reaction precipitate will settle down. Neutralization reactions. Neutralization reactions, what are these? In this reaction, when an acid reacts with the base, it forms salt and water. Acid as well as base lose their properties to form salt and water, which are neither acidic or neither basic. They are neutral. What are they? Neutral. So such reactions we call as neutralization reaction. For example, if we take hydrochloric acid in aqueous form, it reacts with sodium hydroxide, a base, in aqueous form. it will form salt and water. Which salt it will form? Sodium chloride and water. Product will form. Sodium chloride in aqueous form. Okay. Sodium and chloride. Exchange of radicals are there and we form salt and water, and they are neutral. Similarly, if we take sulfuric acid in aqueous form, it reacts with the base potassium hydroxide. What it will form? Exchange of radicals. We form potassium sulphate in aqueous form, and water will form. Salt and water. Now we will balance this equation by putting coefficient 2 in front of potassium hydroxide and in front of water. If hydrochloric acid in aqueous form reacts with aluminium hydroxide base, it will form salt and water. Which sort of salt it will get? We will get as a product aluminium chloride, and water will form. So we have to balance the equation also. Such sort of reactions are known as neutralization reaction because the product are neutral, not acidic, not basic. One activity is given in the book in which they have taken 5 ml of sodium hydroxide in conical flask and dilute it with the test tube of water. Then they swirl the flask to ensure that these are mixed together. Then 1 drop of phenolphthalein they add in it so that it can give the pink color to the solution. Then we will add dilute hydrochloric acid. When we add dilute hydrochloric acid, we will get neutral solution which is colorless. In this reaction, if you see, when hydrochloric acid in dilute form react with the sodium hydroxide in aqueous form, they form salt and water, sodium chloride and water. So this reaction, it is neutralization reaction. The pink color after adding acid, it get vanished and we get this sort of solution which is neutral or colorless in color, and nature is neutral. So this one activity showed the neutralization reaction. Now we will discuss oxides and their nature. Oxides are also important class of compound, and we are very familiar with the common oxides, water and carbon dioxide, because these two oxides play important role in nature and in life processes. Agriculture, industry, these two oxides are more important. Now we will discuss about oxides, their nature, like acid and basic nature of the oxide. Now how these oxides can be prepared? By direct combination. By direct combination, element generally form its oxide when it heated or burned in the presence of oxygen. So such sort of reaction are exothermic in nature. Now by direct combination, we will take the example of some non-metals and metals. Non-metals in case of hydrogen, carbon, sulfur. When these non-metals come in contact with oxygen, mean by heating or by burning, then it form oxides. When hydrogen combine with oxygen, it form water. And similarly, when carbon burnt in presence of oxygen, it form carbon dioxide. and when sulfur burn in presence of oxygen, it forms sulfur dioxide. Now in case of metals, magnesium and calcium, when these metals ignite in presence of oxygen, they form oxides, metal oxides. Like magnesium oxide, when magnesium burnt in presence of oxygen, and when calcium burn in presence of oxygen, it forms calcium oxides. Another method of preparation of oxides by thermal decomposition. In thermal decomposition, oxides of metal and non-metals are formed when hydroxide, carbonate, sulphate, and nitrates of metal are strongly heated. We will discuss some examples now. Hydroxides like zinc hydroxide, copper hydroxide, which is bluish white in color, when undergo thermal decomposition, mean when we heat these hydroxide, they will form metal or non-metal oxides and water in gaseous form. Zinc hydroxide, when heated up, it forms zinc oxide in solid form and water as a steam or gas. Similarly, copper hydroxide, which is bluish white in color, undergo thermal decomposition, it forms oxides of copper, that is copper oxide, which is black in color, and water releases in gaseous form. Similarly, carbonate. Carbonates also undergo thermal decomposition to give metal or non-metal oxides. Now some examples are calcium carbonate, zinc carbonate, lead carbonate, and copper carbonate. Copper carbonate is green in color, and rest these three, calcium carbonate, zinc carbonate, and lead carbonate, are white in color. When undergo thermal decomposition, when these are heated, we form oxides. Calcium carbonate, when heated up, form calcium oxide and carbon dioxide in gaseous form. Zinc carbonate, when heated up, it forms zinc oxide and carbon dioxide is released. Lead carbonate, when heated up, it forms lead oxide and it is yellow in color, and carbon dioxide gas will release. Similarly, copper carbonate, which is green in color, when heated up, it forms copper oxide, black in color, and carbon dioxide is also formed. So, exceptional cases are also there. Carbonates of sodium and potassium, they never undergo thermal decomposition. These are the exceptional cases. Sulfates. Iron sulfate, copper sulfate, when heated up, they form oxides. Iron oxide and copper oxide, which is black in color, you know very well, and which gas will liberate during this reaction? Sulfur trioxide. So during this reaction, you can see iron sulfate, when heated up, it gives iron oxide, and sulfur trioxide is released in form of gas. Similarly, copper sulfate, which is white in color, when heated up, it gives copper oxide and sulfur trioxide, and copper oxide we know black in color. Exceptional cases are there like sodium sulfate, potassium sulfate, and calcium sulfate, and many more compounds with the sulfate are not undergo thermal decomposition to give oxides of metal or non-metal. Now nitrates like calcium nitrate, lead nitrate, now sodium nitrate, potassium nitrate undergo thermal decomposition to give oxides. Like calcium nitrate, when heated up, it gives calcium oxide, nitrogen dioxide, brown color gas will liberate with oxygen. Similarly, when lead nitrate heat, it gives lead oxide, nitrogen dioxide, brown color gas, and oxygen gas will liberate. But exceptional cases are there in case of sodium nitrate and potassium nitrate. Sodium nitrate, when undergo thermal decomposition, it gives sodium nitrite and oxygen will liberate. Similarly, potassium nitrate, when heated up, it gives potassium nitrite and oxygen gas will liberate. You can see in this picture that brown color fumes coming out from the test tube, which shows that nitrates undergo thermal decomposition and forming nitrogen dioxide brown color fumes with oxygen. Your homework that all the reaction given up to the oxides and their nature you have to note down in your notebook and practice this reaction.